All right, so we're going to look into one of the problems with numbers in general, um, which is there's different ways we use numbers, and we're going to also look at the idea of sets in general. And so data we can think about as collections of elements with similar characteristics. Now, what we can do with those elements depends on what those characteristics are. And so what we'll talk about are types of data. And one of the first types of data we have is qualitative. And the root in qualitative is the word quality. It describes something that is not fully measurable numerically, at least not in the form that we're going to use it. And so your book does a nice example, right? You know, choice of major is a qualitative piece of data. Your place of birth is a qualitative piece of data. Eye color is a qualitative piece of data. And from a mathematical standpoint, we can look at these as sets or collections of things, right? So majors, like biology, music, philosophy, right? We have a hard time attaching a number to these or using mathematical patterns on them, though they are a collection of things that have similar characteristics. They all describe a major or a course of study, and so they can be grouped together. They can be data. Place of birth, United States, United Kingdom, and so on. Eye color, blue, brown, green, hazel, right? And there's different descriptions that we can use for eye color. And so this is information that we collect, and it's qualitative data. The other type of data we can attach a number to. We can attach a quantity to. In fact, I actually like using the word quantity instead of number, because number seems to be the named numbers that we have. Well, quantity to me is that amorphous pattern that hides behind it all. And so, quantity data. Let me get that better. Quantitative data, which has the root word quantity in it. And so we can count. And so those would be things like age, weight of the letter, or temperature, using examples in the book. Now, when we look at data, sometimes there are different ways that we can classify things. So, for example, using the book's example here, we have sport-related head injuries. And so we have a sport. We'll go basketball, baseball, football, American football that is, gymnastics, hockey, soccer, softball, swimming, and volleyball. And so these are some sports, and we're reporting how many head injuries were treated in an emergency room in the course of, this is in the course of a year that the data was taken. And so 131,930, 83,522, 220,000, 258, 33,265, 41,450, 98,710, 41,216, 44,815, 13,848. And so if we look at this, this is qualitative data. It's a quality. It describes something. In fact, specifically, it's named quality. And this is a count. This is a measure of counting. And it's a very specific type of counting that we'll look at later. I do want to actually say something that when we're looking at data, we'll look here and go, hey, look, football has a really, really high number of head injuries. And volleyball has a very low number of head injuries, right? And so when looking at data, you can start asking questions about it. But I want to know one thing, though. I would posit that football has more people playing it than volleyball. And so these numbers alone don't tell us enough information, right? And you're going to see that as we work our way through things here, is we'll get data, and we might need to pull some more information out of the data. In general, I think football does have a tendency for more head injuries than volleyball would. But the difference in the number of players, and because we don't have the number of players of the sport, we actually don't know what the ratio of these are. And so just keep this in mind as we start classifying data and you start asking questions of data, which is what you want to do. Remember to think about what you don't know or what you can know, right? Which is something we're going to do constantly. Is we're going to get some data and we're going to ask questions of it. And you should look at data whenever it's presented to you and ask more questions. That's how we want to explore data. And so these are qualitative and these are quantitative. Now, inside of qualitative and quantitative, scroll down here, we have different levels of measurement. And so we'll have levels of measurement. And I kind of want to think of these that we're building our way up. And so we start with the lowest information form, which is a nominal level of measurement. And nominal contains the root word for name. And this is only qualitative data. And so it's using names or labels or any other quality. You cannot do mathematical computations with it. Now, that's not saying you can't count how often a quality appears, but that count isn't the nominal level. The next level of measurement, I'll change colors here for it, I think, is ordinal. And ordinal has order in it. Now this can be qualitative. Sorry about my squeaky voice there. Qualitative data, or quantitative. And what's important about it is it can be arranged in order. But the difference between entries has little meaning. So we could think about an example of the top 5 U.S. occupations. Now right here, this is telling us this is ordinal data because it's the top 5. And so we get what? Personal care aides, registered nurses, home health aides, food service workers, and retail sales. And so these are the top 5. Now notice, these are names. This is qualitative data, but it's ordered. But the difference between these two doesn't do anything. All right, and so these are our first 2 levels of measure. Nominal, it's only names. Ordinal can be names or some quantity, but the difference between entries doesn't have meaning. Let me save this, and I'll start with the next 2. Here. All right, and so our third level of measurement is interval. And this is quantitative. You only get quantities in interval. The data can be ordered. My hands go towards the end here. And the difference has meaning. The 0 is a position. It does not mean nothing. And this is a common thing that we do with numbers. And so, for example, with a thermometer, right, we have 0 degrees Celsius, and we have -4 degrees Celsius, and we have 10 degrees Celsius. This is an interval section of data, and position has meaning, and the difference has a meaning. The difference between here and here is a difference of 10 degrees Celsius. But because the 0 doesn't mean nothing, I can't say that, put -8 degrees down here, and I can't talk about doubling, right? I can't say, well, if it's -8 degrees, twice this temperature. Well, that has no meaning. And that's all because the 0 is a position, right? When it's 0 degrees, it might feel like there's no heat, but there's still a temperature, and it's a positional temperature. In fact, we can get colder. And so the interval has that interval, and the difference between the places have meaning, and position matters, but the 0 is not empty. And that leaves us with our last, which is ratio. And what ratio does is it's similar to interval. It's quantitative only. data can be ordered. Data can be ordered. The 0 means none, which also implies ratios matter. And a good example of that is, well, I'll do a number line here, and there's 0, and I'll count off years. 1, 2, 3, 4. And so someone that's 2 years old and someone else that's 4 years old, I can say that the square is twice as old as the circle. When the 0 means nothing, that there's no years yet, then the ratio between these things has meaning. And ratio data lets us do that. Lets us talk about multiples of things. All right, a good example of this would be in the book. It talks about the New York Yankees. Okay, it's the book, right? And when they won the World Series. We have 1923, 1927, 1928, 1932, 1936, and so on and so on and so on. And what this data here is in an interval. I can order it. But the 0 on the calendar doesn't mean no World Series, right? It just means, 0 AD, which is the year that we start our calendars at. Compare that to, home runs by team, and I'll just do Baltimore, did 253, Boston did 208, let's see in here, looking for Cleveland did 185. Trying to see if I can get a nice doubling effect going on here. I'll just make one up. I'll say, the Gardner Mud Rats 185 did 104. And I can say, because 0 means no home runs, then you can say that Boston scored twice as many as Gardner. There's a ratio meaning to these. And so this is a ratio set of data. And this is what we want to work on is, getting an idea of the types of measures we can do with different types of numbers. And so when we put it all together, when we list this all out, we get the level of measurement, there are 4 types: nominal, ordinal, interval, and ratio. And do we put the data into categories? That's a yes for all of these. Can we arrange the data in order? That's a no for nominal, but it's a yes for ordinal, interval, and ratio. Can we subtract data values? And what I mean by subtract data values is, does the difference between 2 entries make sense? And that's a no for nominal, a no for ordinal, a yes for interval, and a yes for ratio. And then can we multiply or divide? Whoops. Or divide. And that's a no for all but ratio. And so let's look at the subtraction rule here. If I scroll back up here, right? if I subtract 1927 from 1932, that tells me there were 5 years between those two wins. Or if I subtract between here, there were 4 years between the years. And so that's what we mean by can you subtract. Where again, if we looked at the 104 home runs versus 208 home runs, Gardner scored half as many. That means we can divide or multiply. And so that's how these levels of data come out. And so knowing how you're going to measure things determines what math you're going to be able to bring to bear with it. All right, that's chapter 1, section 2. I'm going to pause this, and then we'll talk about section 3.